Hello everyone, I am Xiao Gang. In this lesson, we will do sorting. We know that this TMap is actually unordered, so in Blueprint we cannot loop through it. But at the world context level, which is more powerful than Blueprint, we can sort it. However, once you modify the map, the order might change and the sorting is unstable, because among equal elements, they might be at the front or at the back. Then it can sort using this key-value, or it can also sort using this value. So these two functions can both be sorted using this binary position. Let's take a quick look at this. This is the fruit we defined earlier, and it sorts using the k-value. So, are there two k-values here? And if this is put into sorting, it's equivalent to having the largest one first. It's called a retard, with the largest one first, right? And then it compares this, the integer value, and this value is only for comparison, the length of this string. The shorter one goes first, right? So the sorting should look like this. Let me demonstrate this for you. It looks like we still have to do this operation. Not Orella, it's mapped. Let me take a look here. We might need a host over here. We'll just add one like this. Our host sequence might be different from theirs, but our approach should be the same. We won't need this. Okay, so the first one is sorted by this index, right? What we need to be careful about is that we randomize this order. We'll just add some random stuff, make it more. Okay, let's give an example. Okay, we can take a look at its command. And it is also a template method inside the map. It's about sorting the arrow squad. And using this k-value of the arrow squad as this sort, it's a critical judgment for the sorting, right? It should be, yes, a standard scale. Then we need to rehash the rebuilt maps. And then regarding this volume, it's in this location. See, this area is the volume that participates. Okay, after we perform a sort here, let's look at the result. We have it make a distinction like this. Look at 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct, this is 9. 9 elements. Let's mark this. This is 6. This is 10. This is 5. Okay, let's start now to perform a verification. Then we start it now. Then we enter. We are like expensive elements. It adds them in this order, right? Then we first sort by the letter K. So after arranging them, you will find that the largest one is in the front. So this 10 moves to the very front. So now we sort by these values. After sorting them, they are empty, right? So let's not discuss that yet. We will all verify it. And didn't we previously have this statement? We can do it this way. Then let me see. There shouldn't be any pointers, right? Then we let him apply the one, okay. Then we execute the 10 that we put. Let him use this one, the longest one. We need to use an F3 pointer to connect it. We guess my freight. Then, if we can find this pointer, we'll do it like this. But we can definitely find this pointer. We let it dereference. and then add equals. Modify, it should be called me, right? If we can find it, we will do me this way. Then we have now gone through 2 cycles. After sorting, then we calculate the length based on this character. The smaller ones come first. This 10 should drop to the last digit. So in this position now, it definitely won't be the same. If we manipulate this pointer again, let's take a look. We add equals, modify, add equals, M2. We will now look at the specific effect of this code. Note that this place needs to be dereferenced, because what we are adding here is a pointer. So we need to cast it to a stream. Okay, in this case, we still use int a equals 1. Int 3.2 equals, okay, let's test this here. Now, okay, after we go inside, we can see this area. After we initialize, we can also find this object, right? It is script fade. And then after we add it, we look at this number again. Just add unknown to the script fade. This element is currently supposed to be 2. Then we first sort it alphabetically. After sorting it, it becomes the first one. Then we will use this Weiler finger shape pattern. After it is arranged, it becomes the last one. So we now add an M2. After adding it, we directly look at this number. You will notice that this M2 added to this element that was supposed to be 2. So this is what I want to emphasize. It is an unordered container. Then you can perform a simple sort on it. However, once you modify the contents inside, then all previous point and references cannot be used in this way. This is a KMY6. I have just demonstrated such a simple sort for everyone. If you want to pass your own structure as a k-type, then you might need to implement a k function. We will explain this to you in a moment. How the k function is implemented. Okay, we will finish the demonstration of these classes here